Hello and welcome to a case study by GeoWing Academy, where we have a look at the use of RGB drones, machine learning, and RGB derived indexes for crop health analysis. So can we use RGB data for crop health analysis? Yes, we can, but there are some parameters that we need to consider around the use of RGB drones, such as what days to fly, and how to train our machine learning algorithm correctly, and what to look for in terms of the statistics that are brought down from the health index map. So here we have a strawberry patch, and after running the GeoWing Academy machine learning algorithm over it, we have managed to detect the strawberries themselves very well. As you can see, each individual point here has a different color demarcation that is relevant to the plant's health. So red obviously being in very poor health and dark green being in very good health. So from this information we are able to derive each individual plant's health in terms of the MPRI index, or the Modified Photosynthetic Plant Health Index. So we have quite a number of strawberries in this patch, and each of them has been detected and their MPRI index assigned to them. We can then consolidate this information and work out an overall health for the entire strawberry patch and come up with some statistic information which we can then use to determine the overall health for this particular strawberry patch. But there are some things to consider. So the initial data set was flown on a cloudy day, and this has a big effect on the amount of shadow that's found within the drone map. So as you can see between the two different maps here, the above one being cloudy and the one to the right being captured on a sunny day, the amount of shadow is quite different. This has an influence on the number of detections that the machine learning algorithm is able to determine. This is because shadow often gets confused with green. So we can see here this is the sunny day and there's quite a lot of missing detections. If we have a look at this in the MPRI index, we can see there that there's a lot of green turning up in the shadow, and this leads to confusion for the machine learning algorithm. So if we have a look at our statistics table, we can see quite a lot of very juicy information here on the comparisons between the sunny and the cloudy data sets. If we look closely here at the minimum and maximum values, we can see that the reflectance values differ quite substantially from sunny to overcast. Take a moment to have a good look at the statistics table here and get a good understanding of what the table is actually talking about. So what does this mean? This shows us that to get more consistency out of our data, it is better to fly on cloudy days, because the lower values overall produce much better detections and there's a more uniform light consistency across all of the plants. This means that the index values that we are looking at are far more consistent and will give us much better rounded vegetation health value for the overall crop and for individual plants. Whereas on a sunny day, the light values are too scattered. This then decreases the accuracy of the machine learning algorithm's ability to be able to pick up individual plants, because it's confusing with shadows, and it also means that the very inconsistent light across the patch in terms of the green values will also give very high variations in the plant health index. So this will then skew the data. In order to improve this, we must keep our RGB drone flights to overcast days so we can get more uniform consistency through the crop itself in terms of reflectance values, and we can also give more training data to the machine learning algorithm. Alternatively, using a multispectral drone will give you a much better quality vegetation health map. because the near infrared and red edge bands do not confuse green with shadow in the digital world in those particular values. But using an RGB drone can provide very valuable insights into crop health and therefore provide very good management insights. If you would like to learn how to build your own machine learning algorithm for object detection, go to geowingacademy.com today and have a look at some of the other courses available to you, all related to the use of drone photogrammetry and GIS.